See, climatology. Before starting the climatology, let's go through the few facts. There is something called as pressure gradient force. Pressure gradient force. Pressure gradient force. So for any movement to happen, we need some kind of force, as I told you. So similarly, for the winds to move, there has to be a pressure difference. For the winds, in order to move, there have to be a pressure difference. For suppose, wherever there is low temperature, so there you can experience high pressure. So wherever there is a low temperature, there you can experience high pressure. So wherever there is a high temperature, you will always experience low pressure. Keep it in mind. So low temperature, high pressure, high temperature, low pressure. See, winds will always move from high pressure to low pressure. Winds will always move from high pressure to low pressure. For suppose, just imagine, 1000 MB, here the pressure is. For suppose here the pressure is 800 MB millibars. For suppose in the other case, if the pressure difference is 1000 MB and here the pressure difference is 600 MB. So where is more difference? In the second case, so 1000 MB and 600 MB. So here the winds will travel with high speed. So for suppose, just imagine it's a pipe, horizontal pipe. If I carry it exactly horizontally, so there is very less movement. But if I tilt that, so how much angle I am tilting it, so that much speedily water or anything that is present inside the pipe will come. Getting my point? So the meaning is, greater the pressure difference, greater will be the speed. Greater the pressure difference, greater will be the speed. And the other thing is, lesser the pressure difference. For suppose there is almost horizontal. So lesser the pressure difference, lesser will be the speed. Okay? See, just imagine the water is there in this pipe, a big horizontal pipe. So the way I am this is the high and this is the low, highest point and lowest point. The way the differences is increasing, the water will come down with a high speed. If it is exactly horizontal, the water will not come. So the only thing for the movement is the difference, high pressure, low pressure. So high level, low level. So wherever the difference is so high, then the winds will also travel with so speed. That itself is called as a pressure gradient force. Winds will always move from high pressure to low pressure. So if you just to keep this thing in mind, we can understand cyclones, we can understand anticyclones, we will also understand El Nino, La Nino, many kind of things. But the thing is that just keep it in mind, winds will always flow from high pressure to low pressure. So how a low pressure is created? So high pressure or low pressure. So this pressure is depending on what? Temperature. As I told you, sun is the reason for everything. So in order to cause movement for the winds, the sun is responsible. So in the winter time, in some places there is low temperature, in some places there is high temperature. So this low temperature and high temperature is the reason for the driving force for the wind. So high pressure, low pressure, so greater the difference, the wind will travel with very, very high speed. And the next one, which we need to discuss is Coriolis force. Coriolis force. See, Coriolis force it is basically sensed. Okay, so what is the meaning of Coriolis force? For suppose if the fan is moving. So just if we keep a thread in front of the fan, the thread will also start moving. So the reason for the movement of the thread is nothing but the speed of the fan, rotation of the fan. Similarly, earth is moving. What is the speed of the movement of the earth? Around 1,08,000 kilometers per hour. 1,08,000 kilometers per hour. With that much speed, the earth is moving. So when the earth is moving, Because of the movement of the earth, there are some changes which we are going to experience. That is nothing but we explained in the Coriolis force. Now suppose see, imagine this is a globe. We want to go from this place to this place, from India to US. If it is static, if it is not moving, we can easily estimate and we can easily go from this place to this place. But as soon as if it is moving, if it is static means we can easily go from A to B without any problem by keeping some estimations. But the earth is moving, earth is rotating. As soon as the person starts flying, see on the ground level it's no problem. But if you are flying, so as soon as the person starts from here, as soon as he flies, the rotation of the earth's position is changing. So again he has to plan. So as the earth is rotating, there are some changes which we are going to experience. For suppose see, when you are playing a shuttle, badminton, so if there is no force, there is no much problem. But whenever the wind or air is coming very hugely, very fiercely, will it get deflected or not? Cork will get deflected. Similarly, here also, because of the movement of the earth, there is a force that is getting created that is nothing but the Coriolis force. So, there is a high pressure, there is a low pressure, and there is also a Coriolis force. So, what this Coriolis force is, how can we experience this Coriolis force? We will be discussing. See, this Coriolis force is a zero. This Coriolis force is zero at the equator. So from the equator, so if it goes towards the poles, Coriolis force is maximum. So Coriolis force is maximum. So that means, for supposing the wind is going in this direction normally, because of the movement of the earth, the wind will get deflected in this direction. So the deflection is because of what? Coriolis force. So because of the deflection, because of the movement, the wind is going to get deflected. See, this deflection is more at the poles and zero at the equator. We do not experience much causation of the Coriolis force at the equator. So why it is not experienced more? Why it is experienced less at the equator, more at the poles, we will be discussing that. But to this extent, just imagine there is a Coriolis force and there is a pressure gradient force. So what is the meaning of pressure gradient force? Winds will always move from high pressure to low pressure. So what is the Coriolis force? So because of the movement of the earth, a force can be experienced. For suppose a person want to go to one place, but instead he will be going to the other place. Why will he be going to the other place? Means flying while flying. Or else an object which want to come to one place to another place, but it travels in normal direction, but it is getting deflected in another direction. The deflection is because of the Coriolis force. This deflection is all over the globe, it will be there. But it is zero at the equator, not experienced. That is why cyclones will never form at the equator. Cyclones will form away from the equator. There I will use this concept, but I will explain you there when I explain the Coriolis force. But the deflection is highest at the where? Poles. The deflection will be highest at the poles. See, why the Coriolis force is causing. And after this, there is another thing. That is nothing but Ferrel's law. Ferrel's law. He says that the things which are present, for suppose if we look at the globe, this is the equator. In the northern side, the objects will be deflected right side. In the southern side, the objects will be deflected left side. Just once open the images which I sent you. I think I've shared you multiple images. Open the global winds. Global winds. Second image. Fifth image also. Or something is there. Fifth image. Did you open this? Fifth image. See, these concepts most students will never understand in the books. This pressure builds everything we are going to discuss. So I'm starting from the basic, what is there, what it is there, etc. So this is the pressure gradient force, Coriolis force and Ferrell's law. Ferrell's law, what he said is that by using the Coriolis force, Ferrell's has derived his law. He started saying that the objects, anything that is moving in the northern hemisphere, they will always deflect the right side. For supposing, if the object try to goes to in this way, from this place to that place, it will obviously get deflected towards the right. For suppose, if the object tries to come from this side, so but due to Ferrell's law, it gets deflected towards the left side. So it gets deflected towards the left side. This is what held by the Ferrell's law. Now I will derive this Ferrell's law, Coriolis force, how that will be caused. Just imagine in the northern side they will be deflected right side, in the southern side they will be deflected left side. Okay? So based on this Coriolis force, Ferrell's law, I'll just try to explain you Ferrell's law. How did we came across that? For suppose just imagine. Imagine this is a comb and cylinder. So there is a point A, point B, and on the open space. So this is a point B, point C. Point A, point B, and point C. Cylinder. Imagine this in a 3D format, okay? Just like this. Cylinder. A point is located on this. Similarly, a cone. So that means here the radius or diameter will be less. Here the radius or diameter will be more. That's it, right? So just imagine. I am rotating the cylinder. So this is, I am calling it as a P. So this C, B. So TB. So for maybe just 1 second. 1 second. So for 1 second, I am rotating this one. How much distance that A travel? Distance. How much distance that A travel? Will it be equal to B and will it be equal to C? See, because this is a cylinder. I've just drew a line on the cylinder. I'm just rotating this. I'm rotating it for 1 second or for a certain period. In this 1 second, the distance travelled by the point here means, for suppose this is a point. I'm just rotating like this in 1 second or whatever the time. So this is 1 point, this is 1 point, and this is 1 point. So they are completing one complete rotation. So that means in 1 second, if I am rotating that, the distance travelled by A and the distance travelled by B and the distance travelled by C, if all are equal, can I conclude that the speed is also equal? So simple one, a cylinder I have taken. Based on the distance travelled, I am calculating the speed. I'm not putting any value, X 20, 30 kilometers. Basically, there is no need of any values. So I'm just taking the distance travelled in a particular time. As in case of a cylinder, they are travelling equal distance. So I can call it as what? So equal speed. Now just imagine this cone. So suppose so like this. This is a cone. I'm just keeping a point over here. A, B, and this is the C. I am completing one complete rotation, one full rotation in a particular time being. So this is A, B, and C. So in a particular time, the distance traveled by which is more, which is less. So that means the distance A, so means distance C is greater than distance B is greater than distance C. Yeah, distance traveled by A. So that means C is traveling with more speed. That means speed of C is greater than speed of B, yes or no? Because see, they are completing one same term, but it is traveling more distance. Then can I conclude that C is traveling with more speed? So A less speed, B more speed, C even more speed. Okay? So at the center point it is traveling more speed. So just imagine Earth, and if I am cut, just imagine this is the equator. So now just try to draw the same point over here. So point A, point B, and point C. If Earth is completing one complete rotation, so which point will be travelled more, which point will be travelled less? C will travel more and A will travel less. So based on the distance travelled, can I conclude that the speed at the equator is highest? And again, the speed from the equator to the poles, it will completely decrease. So the speed, anything, for suppose the Earth is moving, for suppose see, if I do like this, if I might rotate my hand, complete rotation, but the distance travel will be more over here. You can feel it is traveling more speed. It is traveling with less speed at the shoulder point. Similarly, in the same manner, here the speed is less and here the speed is more. So means at the equator the speed will always be more. And from the equator towards the poles, the speed will always be less. So that is why I just compared you in this one. If the cylinder, they are traveling equal distance, the speed is same. But in the cone, that is different. Similar to the cone, I am imagining the sphere. So from this, I can conclude that the speed at the equator is the highest. The speed at the equator will be the highest. And from the equator towards the poles, the speed will be decreasing. So 0 do not imagine, but the speed will be decreasing. Okay? So means the thing is, if a person stands over here, and if a person stands over here. So here you can say that the Earth is traveling with high speed. In the seasonality also, you can understand that. See why 24 hours will be there, 24 hours night will be there. Indirectly we can connect that also. But here the speed will be more. And the next concept is, so pressure gradient force, Coriolis force, Ferrell's law. In order to derive the Ferrell's law, I have given you this example. Cylinder, cone and the speed. So from this we can conclude at the equator the speed is more. At the equator the speed is more. And beyond the equator the speed will be less. And the next. A. This is B. This is C. Okay. So A, B, C. All these three bodies are traveling with a speed of 60 kilometers per hour. 60 kmph. A, B, C. And there is another body which is P. Okay. So it is traveling with a speed of 100 kilometers per hour. 100 kilometers per hour. Next, the main target is both are moving. It is moving with 100 kilometers per hour. It is moving with 60 kilometers. Parallelly, they are moving. They are just moving or rotating, whatever it may be. Now, P wants to throw something onto the B. P wants to throw something onto the B. Will it reach the B? Where will it go? Where will it go? So will it go to the C or not? So why? Because, so not exactly, but something, it will be moving ahead. So whenever anything is moving from the faster to slower, from the faster to slower, the apparent will be ahead. Keep it in mind. So whenever any body tries to move or tries to throw from the faster body to the slower body, the target is this one, but the deflection will be here. Why the deflection? Speed difference. Similarly, just imagine in the another case, P this is a P moving with a speed of 60 kilometers per hour, and there are A, B, C. Now all these are moving with a speed of 100 kilometers per hour. A, B, C is moving with a speed of 100 kilometers per hour. T is moving with 60 kilometers per hour. Now P wants to throw something onto the B. P wants to throw something to the B. Where will it get deflected? So it will goes to where? It will go to where? So means anything is moving. If anything is moving from faster to slower, anything is moving from faster to slower, it will be always ahead. It will always move where? Ahead. So this is the faster body. This is a slower body. Anything tries to move from the faster to slower, it will always be moving ahead. If the wind, if there is a high pressure, there is a low pressure. Wind always tries to move from high pressure to low pressure. But the wind will get deflected. Where will it get deflected? Ahead. So why is it deflecting? Because moment. Earth moment is causing what? Coriolis force. As I told you, anything to cause, we need some force. If there is no force, the wind would have directly traveled from P to B. But there is a force. Because of that force, wind, as it is trying from P to B, but instead it is going to where? It is going to the C. So, whenever anybody, because again I'll say, I'll compare with the glue, anything moving from the faster to slower body, so then it is always moving but ahead. So anything which is moving from a slower to faster, which is moving from slower to faster, it will always, it will be deflected behind. So you will learn one by one. Now only you will not understand this. It will always be deflecting behind. So keep these things in mind. So these are the principles which I want to explain you what the mechanism happen when we draw the same thing with regard to the glue. Okay. So this is the first thing. Okay. Just draw this example in a rough manner. I will dictate it clearly, but I am rubbing this one. Just draw this one. No need to, if you want to keep heading, keep climatology. So just keep one number after this diagram. While writing, we can write like a reference to and so diagram, etc. We can use that. Okay, completed. So this is how they will be traveling. So now, if I draw the globe, see this is the equator. So now, this is traveling with high speed. So when you go for this one, compared to this one will be traveling with low speed. For suppose, a wind is traveling, see this is the low pressure because the temperature will always be high over here. And this will be the high pressure, compared to here the temperature will be less. So wind will tries to come from this place to this place. But this is what? Low speed. When anything is coming from low speed to high speed, there will be a kind of deflection. Similarly, if you take this one, so this one is low speed, but see compared to this one will be even low speed, but this one will be high speed in this. When it is moving from the high speed to low speed. So when it is moving from high speed to low speed, it will always what? Go ahead. So as in the above case, so same over here. If this is the low speed, see this is the high speed at the equator, say as it is the equator. Equator will be the high speed. And compared to this one will be the low speed. When something tries to come from this place to this place, so faster to slower. So as I told you, what happened? What I told you? Faster to slower, it will always move ahead. So faster to slower, it will always be moving ahead. So from this we can conclude that, see, it is traveling from this point. So it want to travel in this manner, but it will deflect in this manner. So in the northern hemisphere, where it is getting deflected? Right side. For suppose, here, it want to travel from this point to this point. But in southern hemisphere, it always deflects left side. So why? Because Ferrels have said that because of the Coriolis force, it will be getting deflected towards the left side in the southern hemisphere, and in the north side it is getting deflected towards the right side. So instead of saying simply, this will get deflected towards the left side, this will get deflected towards the right side, I explain you with that particular example. See, the earth's speed is not uniform all through. Equator, it is high speed. From the equator, if we go gradually up till towards the poles, the speed what happens? Decreases gradually. Every time, we will be comparing 2 points, any 2 points. Maybe this one or this one, maybe this one or this one, and we will be drawing like 0 degrees, 30 degrees, 60 degrees, 90 degrees north. Similarly, 30 degrees south, 60 degrees south, 90 degrees south. We will be drawing like that. We will be comparing between 0 degrees and 30 degrees, or 30 degrees and 60 degrees, or between 0 degrees and 30 degrees, north side. So everywhere we have to keep it in mind. If it is traveling from speed to slow, or whether is it traveling from slow to speed, whatever it may be. So you have to take these two things into mind, slow to speed or speed to slow. So if you feel this is very difficult, you can just remember, in the northern side, the wind will always get deflected towards the right side. In the southern side, the wind will always deflect towards the south side, or left side. Okay, this is the north and left. This is what held by the ferrule. In order to deduce that ferrules, I have explained you this. So from this we can conclude that. So what I am going to say is that pressure gradient force. There is force that is required to make the winds to move. The thing that is making the winds to move is pressure gradient force. At any time, there can be high pressure or there can be low pressure. High pressure and low pressure is always depending on the temperature. Temperature is always depending on the sun. And how the sun is moving, we discussed in the seasonalities topic. On June point, one point will be there. On December, one location sun will be there. On the equinoxes, sun will be there at one point. So, we discussed that overhead of the sun. So, sun will be overhead at on the Tropic of Cancer on one time, Tropic of Capricorn on another time, and equator on the other 2 times. So, as the sun is changing, sun's direct falling of the sunlight will also change. Whenever the sun's direct falling of the sunlight will change, the pressure will also change. Wherever the sun is falling directly, there you can experience more temperature, there will be low pressure. On the other side, there will be high pressure. So, winds will always move from high pressure to low pressure. So, the next concept which we are discussing is nothing but prevailing winds. The next concept which we are deriving is nothing but prevailing winds. So what is this prevailing winds? What is this prevailing winds? Means 365 days all throughout the year, there will be certain winds every time. Every time there will be certain winds. Those winds I'll be calling them as a prevailing winds. Those winds are also called as a global winds. So there are some kinds of winds are there which will be there 365 days. So every time they will be there. So those winds are called as global winds or prevailing winds. What are those winds? How will they travel? We will derive by drawing the map, by drawing the globe. Okay. So that is why, in order to make you understand, I just try to derive you these things. Okay. So anything in the northern hemisphere will always deflect towards the right side. Anything in the southern hemisphere will always deflect towards the left side. So why right side, why left side, I explained you with these examples. So the speed of the earth is changing, the speed will be more. So depending on from what direction to what direction they are going to travel. That is what we derive. Okay. So this is the pressure gradient force, Coriolis force, Farrell's law, and in order to deduce the Farrell's law, I told you. And the next concept which are we discussing is nothing but the prevailing winds of global winds. Okay. Now let us go for this prevailing winds of global winds. See, this is the globe. As we discussed, at the equator, what will be there? So temperature will be high. So you can consider, like 10 degrees, or else just imagine 5 degrees north to 5 degrees south. Just imagine like this. There is a point. This is 5 degrees north to 5 degrees south. This is also 5 degrees north to 5 degrees south. Next, what the thing is going to happen is, there are two kinds of things. Hadley cell. Hadley and a Farrell. What did they told is, what Hadley have told is, whenever at the equator the temperature will be more. At the temperature is more at the equator, the wind will always rise. As I told you, the wind will rise up to what point? Tropopause. See, beyond the tropopause, the wind will not travel. Why the wind will not travel is because, so wind will travel to the highest point, tropopause. So if it is hot, it can travel. But beyond the tropopause, it will be cool only. So after going there, it will always descend. So what the Hadley have told is, the winds from the equator, means the convection. So whatever the air is there at the equator, they will always rise. They will always rise. After going to the tropopause, they will get deflected. They will deflected and they will go to the pole. Again at the pole, they will be descending. Again they will be coming down and they will be rising. So how he held is, see, here the wind is rising. After going there, it starts deflecting towards the poles. See, in this manner it is traveling. So after going to the poles, it gets deflected. So how it gets deflected again? It will come back to where? Equator. So why will it come back to the equator? Because at the equator, the temperature will be more compared to all the places. So as I told you, see, air want to rise. It can rise at this place, it can rise at this place, it can rise at different places. Everywhere if the air goes, but the required energy will not be there to cause the rainfall or to cause some mechanism. So what will they do? All the similar things. So all the winds, they will come together and from one particular place they start rising. So what Hadley have derived is, by using the convection cell, so whatever the convection current is there, convection moment is there. So he said that, see, I can draw from here, this is the place, from here the air is rising, it will deflect and it will go there. But I cannot draw this on the board. That is why I am drawing like this. Okay. So from here also, it is rising. So from this side also, it is rising. And after reaching the tropopause, it will go to the poles. And after going to the poles, again it will come to the equator. So this is how it is traveling. This is how it is traveling. So this is how the wind is traveling. This one is called as Hadley cell. Hadley cell. He said that just the wind, see basically there will be balance is required. In the equator, there is excess amount of temperature is there. But the poles, there is very less amount of temperature is there. At the equator, more temperature is there. At the poles, less temperature is there. But in order to balance, we do not require more temperature. They do not require more cool temperature. So what the nature is doing, whatever the excess heat is there, it is traveling that heat and it is transferring into the poles. Whatever the excess coldness is there, it is bringing that from the poles and it is bringing that to the equator and it is balancing that. So how the heat from here is traveled to the poles, how the cool from the poles is converting to the equator. So that one he explained in the form of a mechanism. It does not mean that there are other winds. There are many types of winds are there. But all throughout the year, all 365 days in a year, there is one mechanism, one process that always builds. That is nothing but, first of all, here the air is rising. Here the air is rising. And after tropopause, the air is getting descended. So it is traveling continuously up to the poles. This is what held by the headling. Okay? But scientists have completely rejected this headley theory. Why did they reject it is, yes, whatever you said is fine. The wind is traveling up to tropopause. It is deflecting. But after deflecting, why will it travel this much distance? It will deflect at the same place, right? For suppose, see, the wind is traveling. It reaches the highest point. It can deflect the very next moment, right? Or after that moment. So means Hadley didn't consider the movement of the earth. Hadley has given this theory by imagining earth is a constant body. When constant body is, obviously it will happen. But he forgot or he didn't kept in mind that the earth is moving. So that is why scientists have completely rejected this Hadley theory. Then after his disciple Ferrel came into existence, he came up with a concept called as Coriolis force. There is something called as Coriolis force. Mr. Hadley, whatever you said is fine. The wind is traveled to the highest point, tropopause. But after reaching the tropopause, it will directly not go to the poles because Earth is moving. Because of the movement of the poles, so here you can experience some force. In the higher altitudes also you will experience some force. So that will get deflected. So that is why Hadley's theory was completely rejected, and in that place, which theory came into existence? Ferrel's. We'll discuss that. Okay. So just draw this point. So until unless this class completes, everywhere there exists a question mark. And if you miss even one point also, again you will not get anything. So that is why I explain you basics very clearly. So without that you will not understand. It will be like rote learning for you. So just open the image which I sent you. Low to height?
From here it is long.
Hmm.
Height is little troposphere, end of the troposphere.
Hmm.
And when it reaches here the height decreases.
Hmm.
When coming it should be same comes. It is height is increasing.
ఇక్కడ ఇదా yeah, normal I wanted to tell you that the height will decrease. That's why I just decrease this one. Decrease. ఖచ్చితంగా decrease అవుతుంది. I think you can understand that headless cell. Did you open that? Headless cell. So this is headless. Okay. So now headless theory was proved as wrong. So what he imagined is fine, but that is not going to happen because Earth is rotating body. There will always be a Coriolis force, and because of Coriolis force, at one point of time it will definitely gets deflected. Okay. This is what held by the headless cell. Okay. Next, against this headless cell, what the Ferrell have told you, what is the Ferrell's law, etc. I'll derive that. Because in Ferrell, he derived Earth's zone into in this manner. (30° north, 60° north, 30° south, 60° south, 90° south, 90° north. Now let us imagine. What about the pressure over here? Here, what about the temperature over here? So here the temperature will be high. Hence pressure will be. So what you can experience? Low pressure. So around this 30 to 35 degrees, you can include like this 30 to 35 degrees. What about the pressure over here? See, I am writing like this. Subtropic high pressure belt. So it is high pressure. Compared to this one, this is the high pressure. So similarly, this one also will be what? So subtropic high pressure belt. See, the temperature will be more over here, fine. But compared to this one, the temperature will be less. Temperature is less means high pressure. Temperature is more means less pressure. So now let us imagine. See how the winds will travel generally. North to means high pressure to low pressure. So compare this to, let us compare this to high pressure and low pressure. So wind will try to travel from which, how it will try to come? High pressure to low pressure. But as I told you, in the north side, where will they get deflected? Right side. See, compare this one, from where is it starting? So as it is starting in this direction. So as it is starting from this direction, right side will be like this. So instead of coming like this, it will get deflected. So how will this get deflected is, this subtropic high pressure belt, the wind will travel in this manner. Wind will travel in this manner. wind will travel. So all throughout the globe, the wind will travel in this manner. So this is how the winds will travel. And now same like here. Wind want to go from which place to which place? Why do wind want to go from high pressure to low pressure? Pressure gradient force. What does pressure gradient force say? Wind will always travel from high pressure to low pressure only. We need, see, so water will come down only when there is a slope. Why the water will come down? Slope is the reason for the water to come down. So winds will always move. Greater the pressure difference, more the winds will come. So that is how. So high pressure and low pressure. Winds will travel from high pressure to low pressure. See, as it is traveling in this direction, I have to pace in this direction. It will deflect where? Left side. So instead of going in this manner, it will be going how? Left. Left. See, the first question arises for you is again the imagination. Why the wind is going in this direction? See, our imagination will be like Hyderabad or India or Asia. But here I am not considering any country. Here I am considering the globe. How the earth is there, how the sunlight is falling on the earth, and because of sunlight, what are the mechanisms going to happen? See, for suppose there is a summer season, winter season, rainy season, everything will be there. That is periodic, not every time. There are even day-to-day changes will also be there. Low will be there. So, dust winds will be there. So, day-to-day changes will be there. Month-to-month changes will be there. And year-to-year changes will be there. So, I am speaking about yearly, global winds. This will be there every time. See, there is prevailing winds, there is periodic winds, there is local winds. Local winds means only in one particular place the local winds will be there. Periodic winds in particular period for months together, that will be there. Global winds all throughout the year it will be there. For suppose see, just imagine a person. If I call generally a person as a good person, very very good person, but it doesn't mean that always he will be good. For suppose a person who is very soft spoken and who is very calm and peace loving person. So generally it is generalized concept. But sometimes he will also become very much anger. But we are not speaking about that. We are speaking about generalized thing. See, if we discuss about climate, this is summer, this is winter, this is rain. But weather pattern will also be there. So here what I am speaking is all throughout the globe, every time, India, Russia, Australia, USA, UK, Mexico, whatever it may be, everywhere, all throughout the globes, there will be some pattern of winds. Winds we will not be observing the winds. So for suppose when we fly the kite, based on the wind or air direction, the kite will fly. So that means there will be some local kind of winds will be there, but this will be there every time. But one or the other way, the domination will decrease, the domination may increase. For suppose monsoon, when the monsoon comes, they are called as a periodic winds. Their domination increases, does not mean the global winds will not be there. These global winds will be there every day, all throughout the year. Once we understand this, we will understand the periodic winds. We will understand how the climate system in India will get impacted. So that is what. See, this one is completely called as polar high pressure belt. So this one I can call it as a subpolar low pressure belt. SR. See, compared to this one will be cool. But compared to this will be a bit hotter. Right? So, I am not comparing this one. I am comparing this one. Why did I compare? Means the domination will be more of high pressure over here. So, this is high pressure. And this is low pressure. And in some books you can also find temperate low pressure belt. Temperate low pressure belt. You can also find it as a temperate low pressure belt. So tell me, now just let us discuss high pressure to low pressure. So, as I told you, winds will always move from where? High pressure to low pressure. So here it is traveling from high pressure to low pressure. But see, as it is traveling in the northern side, where will it get deflected? It gets deflected right side. So instead of going in this path, it will be going in this path. See, for this, I am faced in this direction, and for this, I am facing towards the board direction. Because you have to see the starting point, you have to make yourself present in the starting point. And next, similarly, this is subtropic high pressure belt, and this is going to be what? Temperate low pressure belt. See, again, the winds will be traveling from where? High pressure to low pressure. But when it is traveling from high pressure to low pressure, it will be deflected left side because it is a southern side. Southern hemisphere, they will be deflecting left. So where will it go? It will be going in this direction. Okay. So this is the left side. This one. And the next. See now, the wind want to come from high pressure to low pressure. So when the wind is trying to come from high pressure to low pressure, it can come. Because of the Coriolis, what is happening? Deflecting towards right side. So that means getting deflected towards the right side. And see here, this is a polar high pressure belt. So wind wants to travel from high pressure to low pressure, but it will deflect left side. See, let us imagine. I'll just tell you. So this is the equator. This is a body traveling with high speed. And this is a body traveling with low speed. See, when the body, as I told you, just imagine three things. So when the body traveling from low speed to high speed, it want to travel to here. So but because of low speed, it will travel where? A, B and C. This is the P. So P is traveling with low speed. I am considering these 2 points. Okay. So this is the low speed and this is the high speed. Body traveling from low speed to high speed. It will travel even more fastly. Instead of going here, the body will get deflected this way. And similarly, I'll just draw it over here. Similarly, see, this is the high pressure. And this is, see, this is faster. And this is slower. Yes, sir. So from here the speed will ultimately decrease. So now just imagine. (100 kilometers per hour) and this is 60 kilometers per hour. I want to travel from P to B. A, B and C. I want to travel from P to B. It is traveling with 100 kilometers. It is traveling with 60 kilometers per hour. Where will it get deflected? So did it got deflected or not? In simple, I told you, in the northern hemisphere, they will be deflecting right side. In the southern hemisphere, they will be deflecting left side. So what is the reason is? This is the reason. Earth is spherical in shape. Earth is not cylindrical in shape. If it is cylindrical, we would not have got this thing. So because of the spherical shape of the earth, because the speed of the earth is different at different places, equator the speed will be more, at the poles the speed will be less, and poles Coriolis force is more, at the equator Coriolis force is 0. So Coriolis force, speed of the earth, and also frictional force will be there, pressure gradient force will be there. All the combination, the winds are in this direction. Now, just imagine this diagram, second diagram. You can see the global winds, air circulation pattern. Also look at this R, image named as R. This one. Only I drew the inside part. Now if you understand this, now we'll connect with the sideways. What will be there, etc. Understood this point? How the winds are going to there, how the prevailing winds are there, and now see there are doldrums. So what is the doldrums and what is the subtropic high pressure belt? We will be discussing this one clearly. So equator, it is also called as intertropical convergence zone. So it is called as subtropic high pressure belt and it is called as horse latitudes. So doldrums, horse latitudes will be there. We will be discussing that. But before that, draw this diagram. Coriolis force is more at the poles, zero at the equator. So Coriolis force. What? You're asking me to repeat. So Coriolis force, it is nothing but deflection. Whenever the earth is moving, because of rotation force of the earth, something we are going to experience, that is the Coriolis force. The experience is nothing but the deflection. The deflection will be zero at the equator. Speed will be there. See, what you will be imagining is, as the speed of the earth is more, Coriolis force will also be more. This is your general imagination, but that is not true. So the Coriolis force is more less at the equator, but the speed is more at the equator. And similarly, the Coriolis force is highest at the poles. Means the deflection will be experienced more at the poles than at the equator. I'll give you a definition of this Coriolis force.
Sir, these laws act only on the global winds
Yes.
or on the seasonal winds?
Seasonal winds also.
Sir, if it acts on the seasonal winds, monsoon in India arises due to the north.
No, you will come to know that. See, this will be there. This will be sometimes intensify that, sometimes will de-intensify that. See, El Nino is there, and Indian Ocean dipole is there. Southwest monsoon is there. Southwest monsoon will every time come, but sometimes it is getting impacted by the El Nino. Sometimes there is a low pressure created in the Bay of Bengal. You will be experiencing cyclones. See, periodic winds is different. Once if you understand this, we can connect that one. So in a one line we cannot connect. By and by, over the step-by-step process, I will make you understand. After this entire concept, you will relate everything, correlate everything. That is different, and this is different. And there is no separate partition between these two. There is an interconnection between these two also. See, basically, in this region, you will find deserts at the western side. And in this region, you will find deserts at the eastern side. Why will you find deserts at the eastern side? Why will you find deserts at the western side? I'll give you that also. See, winds are there. Winds are traveling the moisture. So, in order to cause rainfall, we definitely require what? Moisture. So, when the winds are traveling in this manner, they are carrying the moisture. But by the end they are reaching to this point, they are left with no moisture. When they are left with no moisture, there is no proper rainfall. So that is why In this, see, 30 degrees north to south, on the western sides of the continents, you can experience deserts. Between 30 degrees to 60 degrees, see where the winds are completing their end, there you can experience the deserts. Why desert means? See, just take an ice cube. So, a freshly made ice cube is there. I am traveling from here. Here the ice content will be more. By the time it is reaching to that other end, what happens to the ice? It will be melting. There is no source of ice at all. Similarly, in this place, yes, even though they are coming from the oceans, they are having enough amount of moisture. But by the time they are reaching the end point, they released all the moisture in the middle. So they are left with no moisture, and that is why there is less rainfall, and there are more deserts on the western sides of the continent. This was asked by the UPSC in the year 2021. So there are more deserts on the western margins between 30 degrees north to 30 degrees south because of the prevailing winds. Yes, because of the prevailing winds, there are deserts. Okay, I'll give you the theory also, everything. But I'm just telling you why the deserts will be there, etc. And moreover, we will also be coming across cold current and the warm current. Cold current is also reason for the desert.
From 90 degrees to 60 degrees, we are moving downwards. From 30 to 60, we are moving upward. Why we are changing direction? We are moving the same direction from up to down, up to down.
That's what Coriolis knows. When Headley imagined, no, annate Headley అదే తీసుకోండి. He just imagined they went to the north and they are coming to the south. But Earth is rotating now. Because of the rotation of that, there will be Coriolis force. The wind will not come directly. That's what I told you example of this badminton. When we are playing the badminton, we are throwing in the same direction. Our efforts are same, but the effects are disturbing by the nature. Because of the speed of the winds, the direction of the cork is changing. So similarly, as you said, yes, the winds should come directly. But instead, the Coriolis force, the movement of the earth is deflecting. And only temperature difference vasthundi. Because of the difference in temperature, pressure difference are going to happen. Because of the difference in pressure, again, the same things are going to happen. That is why Headley said the same thing. But the same question like you. So by keeping the same question, Headley gave the same thing. They are coming in one direction. But that has been told as a wrong, and that was been replaced by the Ferrell system.
Clarify. Coriolis force. So these are subatomic high pressure element. These are all imaginary.
Imaginary, but the pressure will be there. Because here the pressure is more. That is why it is called as imaginary. But they can imagine even here also. They can imagine here also.
Gangs.
Yeah. And see, yes, this is very important. Why I have imagined subtropic high pressure belt at this point 30 degrees north? Because the temperature is. For suppose, imagine, see, why I imagined this low pressure at the equator? Temperature is. But see, when the sunlight is falling, so sun is changing. Yes or no? Suns will be overhead at Tropic of Cancer. Sun will be overhead at Tropic of Capricorn. Sun will be overhead at the equator once over. So for suppose when the sun is when the sun is trying to intensify all the temperature at this point, this pressure belts will change. So keep it in mind. See, all these are imaginary things. See, why I am imagining this one at 30 degrees is because, or the 0 degrees is because the temperature is more. But during the summer in the northern hemisphere, the temperature will be more at the 20 degrees, not at the 0 degrees. So, all these things will shift a bit north side. Means, instead of 0, it will be going here, Instead of 30, it will be going to 40. Instead of 60, it will be going to 70. See, all these are imaginary. See, why I am imagining high pressure means at this point the pressure is high. For suppose pressure is high at this point, that will decrease. ఓకే అంటే ఏం చెప్తున్నానంటే ఈ ప్రెషర్ బిల్స్ ఏవైతే ఉన్నాయో దీస్ ఆర్ ఇమాజినరీ థింగ్స్. దీస్ ఆర్ డిపెండింగ్ ఆన్ ద టెంపరేచర్. ఇఫ్ ద టెంపరేచర్ ఈస్ చేంజింగ్, see why it is low pressure, because the temperature is more. If the temperature is more at this point, then this equatorial low pressure belt will shift to this one. If the temperature is highest at this point, then the low pressure belt will be here, high pressure belt will be here, again low pressure belt will be here. So these 2 points will be fixed, north pole will be fixed. But between this, these are going to change. Keep it in mind. In next class I will draw the 4 diagrams. See, December 22nd, what is it? Winter solstice. So then the pressure belts will shift below. In the June 21st, summer solstice, then the pressure belts will shift above. This one is at the equinox. So when the sun is overhead at equator, what is happening at the equinoxes? See, winter equinox, September equinox, March equinox. In the equinoxes means the subsolar point, the highest point of the sun will be at the equator. So that is why the highest temperature will be at the equator. So this will be at the equator point. The same is going to change with regard to the winter solstice and with regard to the summer solstice. Once I draw this one, you can understand this. Okay? So let us repeat. So what is the pressure gradient force? Very good. So pressure gradient force, what does it says? What is it says is that, so we will always move from high pressure to low pressure. So don't, whatever the matter, if there is a pressure difference, maybe 1 MB also, they will change. But greater the difference, more will be the speed of the wind. Lesser the difference, less will be the speed of the wind. Traveling will be same. See, this is the high pressure, this is the low pressure. Wind will travel from high pressure to low pressure. But if there is more difference, obviously the pressure difference will be there. Okay? So means they will travel with more speed. If there is a less difference, for suppose, as I told you, 1000 and 1080, less difference is there, they will travel with less speed. 1000 and 1040 on the other side, more difference is there, they will be traveling with high speed. So that is what we need to understand. High pressure. Okay? So we discussed pressure gradient force, we discussed Coriolis force, we discussed Ferrell's law, we discussed Headley's law. So what did Headley consider this? So from here, it will be completely rising and it will be going to the poles and it will be coming back to the equator. Here, they will go to the tropopause and they will be going to the poles and they will be coming to the equator. So he imagined the earth as a fixed object. That is why he imagined it like that. But Ferrell came to conclusion, no, earth is not a fixed object, it is going to change. So what is it going to change? Again, we will continue this one. Okay? I'll draw here, same continuation. I'll draw here, see. See, just here, as it is equator, as it is high temperature, low pressure will be there. So what happens in the low pressure? Air will always rise. To what extent it will rise? Up to tropopause. Okay? So just imagine. Here, likewise it is traveling. It is traveling. So it is reaching the tropopause. So after reaching the tropopause, it gets deflected. So it is getting deflected in this manner. It is getting deflected in this manner. Sir, why will it get deflected? Suppose just there is a flow. If you just pour water, after reaching the wall, it divides in 2 ways. Yes sir. Here, wall kind of thing is there created by the tropopause. So tropopause is behaving like a wall. So the winds are coming in this direction. After hitting the wall, it is divided. Fine. So now it wants to come directly to the poles. But what happens because of the Coriolis force? It is deflect. See, you can imagine it can deflect at the same moment. It can deflect at the same moment and it can directly come down. But as I told you, it requires energy. So it is gathering the energy. So that is why until unless it gets the energy to come down, it is traveling. So it is traveling in this direction. So again, it is coming down. So that means, see, here it is rising, descending, and it is going to descend. Similarly, this one also, it has risen, it has descended, and it will come down over here, and it will come down over here. It will come down over here. Okay? So this is, see what happening means. See this, just imagine on the ground. See, for suppose this is the ground. So all the hot air from here, everywhere, the hot air, it will come down at the middle class, and from there it will rise. So here also, this is the equator. Above the equator and below the equator, as it is more temperature, all the hot airs from all the places are coming down. So that is why, see, they are coming down in this manner. They are uniting. So here also they are uniting. So they are uniting, they are coming here, they are coming here, they are coming here, and they are rising from here. You can look at this. So winds, they are coming here, and they are rising, and they are descending, and again they are, after getting deviated, again they are descending. See, here, they are coming down, they are rising. See, all through the places they are coming down, they have risen, and they have deflected, and they have descended. Descending, the force is required. See, as I told you, when I throw marker above, after reaching one place, it will definitely come down. Some force is required. I told you gravitation. So the wind, the air which is carrying the moisture, it is going above. Again it has to descend. Some force is required. So the Coriolis force is pulling it back. And Coriolis force is not there. Why the Coriolis force came into existence? Rotation of the earth. Headly imagine there is no rotation of the earth. So that is why it didn't came down. It directly went there. But rotation of the earth is there. And see, don't imagine. So yes, the wind will come here also, but very, very minute. But most of them, they will come together and they will descend over here. So next. And the next, see, again where will they are going to rise? Here. What is it saying? Low pressure. And here what is it saying? Low pressure. So once I complete this, you can understand this. See, low pressure. So this is temperate low pressure. Temperate low pressure. It is traveling. It is traveling. See, the winds from ground, it will come here. The winds all through the ground is coming here. The winds are coming here, and the winds are rising here. The winds are rising here. So from here, all the winds are coming. So all the winds are coming over here. All the winds are coming and they are rising at one place? 60 degrees north. So they are rising. To what extent they will rise? Up to tropopause. After reaching the tropopause, they will deflect. So now it is deflecting in this manner. It is deflecting in this manner, and it is coming down in this manner. See, they are rising. So in below, all the winds are uniting. All the winds below are uniting. After getting united, what it is happening? They are rising. They are reaching a tropopause. After reaching the tropopause, they are descending. So here they are descending. They are descending. They are descending. And here they are mixing. So they are converging at what? High pressure. Wherever there is a, they are coming here, again they are diverging. Coming here again they are diverging. So here you can able to see divergence. Divergence. And there is a convergence at low pressure. So this is the low pressure. And here what are they going to happen? Converge. Wherever there is a conversion, it is low pressure. And wherever there is a divergence, it is high pressure. So here you can just writing it diverge. And it is converging. So this is all about winds. So from here they are traveling. See how the nature has arranged itself is. The heat from here is traveling here. See, rising, descending. Same will go here. Rise. Again they will deflect. So instead of going directly, it is going there, coming below and going there, again rising. Means it is taking the turns. Why is it taking the turns? Is because of the Coriolis is it? Ink system. Coriolis. Same over here, low pressure. So what is it happening over the low pressure is? You can see here. Again, see, all of them are uniting. All the high temperature winds, all the high temperature winds, they are coming, uniting. They are rising. They are rising. So after reaching the tropopause, they will descend. After reaching the tropopause, they will descend. So we need to give directions. Likewise, they are traveling. Likewise, they are traveling. So diverging, diverging, diverging. Here they are converging. Here rising, rising, rising. They are going in this manner, going in this manner, again coming here, and they are converging here. So that means this place they are diverging, and this place they are converging. So this place again they are see both of them. Here they are converging, and here they are diverging. See, one way they are diverging, one way they are converging. Converging, diverging, converging, diverging. Okay. Again, by using this convergence and divergence, we will be discussing cyclones and anticyclones. So that is why step by step I just made you to understand. In the initial phases, it seems like why am I telling that? Nobody will tell you. They will directly draw this one. They will ask you to just imagine right side, left side. So just imagine on the northern hemisphere they will be deflecting right side, southern hemisphere left side. But I gave you the reason why it is right side and left side, and also taken each and every example. So that is why you see this is called as a polar cell. These two things are called as polar cell. Just imagine the diagram R. Open the diagram R. See, this is called as a headless cell, and these two things are called as a feral cell. So they were named in different manner. Feral cell, Hadley cell, Hadley cell, feral cell. This is acting like one complete cell, isn't it or not? That is why these cells are given different names. Draw this one. Draw along with that. If the space is not there, again draw the circle, again go for that. See, just open this one, this last image. OIP. Open the image OIP in the group. OIP. Can you see subpolar low pressure belt? Last image means last document. OIP. Subpolar low pressure belt, subtropic high pressure belt, equatorial low pressure belt means they have given it as zone. Subtropic, see this one I told you, subtropic high pressure belt. So subtropic, subpolar low pressure belt, or it is also called as temperate low pressure. See, subpolar low pressure belt, or it can also be called as temperate low pressure belt. And below that one I gave you STHPB, subtropic high pressure belt, and this one is equatorial low pressure belt, ELHB or ELPB, equatorial low pressure belt. The only difference is Headley said to go in a straight manner. Ferrell said zigzag manner. So why zigzag, why straight is rotation of the earth. Earth is not steady, else you can go straight, but zigzag. See what the nature is. Wind, the air which is there, is one point of time it is going to up to here, again is coming. So even the carbon dioxide, whatever it may be, why will they go impact the polar things? Because of this pressure belts, because of this polar winds or prevailing winds. These winds will be there every time. They will always travel. They will always travel. These winds will always travel. Completed this one? Not yet. Bharadwaj, okay now? Vastunda? Answers petal mar next class week anta. Hmm. Hmm. Where you are asking? Not getting your question. Yeah, if the insulation is high, again it will change. The pressure belts will change. Not getting your question. Not understanding. And ask clearly. Else after the class you come to me. Emanta? Obviously high girl. Because equator itself will receive the high temperature. See, sun will not be overhead beyond the tropics, I said you. Sun will be at the subsolar point 2 times. At the vernal equinox and the autumnal equinox. September equinox and the March equinox. So sun, more insulation will be required, taken by the equator. That is why here equatorial region, more temperature will be there, more rainfall will be there. Continuous temperature, continuous rainfall. If anything is decreasing also, we will not get the balance. So there is more temperature and more rainfall. But see, again this will change. Keep it in mind, in the next class I will show you, these pressure belts are going to change. These pressure belts are going to change. Okay, in a nutshell, I'll just tell you. Whatever, see, 30 degrees north to 30 degrees south. So just imagine that is 30 degrees north, that is 30 degrees south. This middle way is the equator. All the winds coming together, the rising over here, and this is the tropopause. So after reaching there, again they are going to deflect. Again they are coming down. While coming down, now earth is the wall. Again they are going to distract. See, as going above, they are dividing into two wings. While coming down also they are going to divide into two wings. See, here they have raised, they have deviated, they are coming down. One wing will be coming this side, one wing will be going that side. Okay? That's why my answer for your question. Why the wind is going that way, this way, this is a wall, this is the solid part. After getting that, it will definitely deviate. Okay? So this is what about the ferrets. Now, I will only draw this one. You will understand even more clearly. Okay? I will just draw only this part, I will just remove this one. So that you can understand even more clearly. Okay? Any doubts in this? See, 0 degrees, equator, 30 degrees north, 30 degrees south, 60 degrees north, 90 degrees north, 60 degrees south, 90 degrees south. Listen carefully. This is the equatorial. So the winds which are there at the 30 degrees means from both the places they are coming together. Why they are coming only at the equator? Because compare in all these places, more temperature is at the equator. See, for suppose there is one strong person and XYZ are the weaker persons. Always, whenever they are having any problem, they will come to the stronger person only. So, this is a weak one. They are coming to the strong one, that is at the equator. Wherever the strong person will be there, the same deviations will be there. So, this place is going to change, we will discuss that. Okay. So, they are coming together and they are rising. Rising. They are rising. So, like this. They are rising. Rising. Not only 2, they can be 3, they can be 10, they can be 100, they can be 1000 also. But we cannot draw that over here. I am drawing only 2. Alright? This was likewise. So this is the tropopause. What will that happens? They will get deflate. So they try to go to 90 degrees, but they will not go. Why will they not go? Because of the rotation of the earth. Because of the rotation of the earth. This is one cell. I am calling it as what? Hadley cell. Hadley cell. Next. Next. See, this is subtropic high pressure belt, equatorial low pressure belt, and this one will be subpolar low pressure belt. So low pressure belt means again the winds from here will come here, the winds from here will come here. They will come here. Again they will rise. They are rising. They are rising. So after rising, they will what? They will deflate. So rising. Rising. So they are coming in this direction. The wind is coming in this direction. Wind is coming in this direction. Rising. They are diverging here and they are also coming here. And here also 60 degrees south, they are coming together. They are coming together. They are coming together. See, from here the winds will come here. From here the winds will come here. In this direction they are coming. In this direction. Rising, rising, rising. They will meet at a particular place and they will distract. So likewise they will be there. So next, see, here I am writing it like this. Diverge. And here, converge. Here, diverging. Here, converge. Diverging. Converge. Diverging. Converge. So converge, diverge, converge. So again here they are converging. Here they are diverging. So this one, I'm calling it as what? Ferrel cell. Ferrel cell. This is a ferrel cell. And this is a polar cell. And this is a polar cell. So like this. So here the wind is rising, it is coming down. See, it doesn't mean like it will be going in its own path, it is going in its own, it's not like they are mixing each other. So the wind will come here, the wind will go here. But in a nutshell I am giving it. So the wind will come here, it will go here, it will rise here, the same wind will go. See, for suppose take X wind. X wind coming here, it is going here, it is going in this manner, it is again rising, again it is reaching to the pole. So that means the hot air from here, they will travel to the pole. Cool air from the pole is traveling here, rising, going here, descending, again it is going to the equator. So cool air from the pole is going to the hot equatorial, hot air from the equator is coming to the pole. In this manner they are traveling. Okay? So that is why again I see here, it is the globe. You can imagine the globe here. It is above the globe. As I draw, beside one. So that one, again I just draw in a broader manner. I just do that in a broader manner. So that is, it is an extension of the below one. Okay. So as we cannot draw 3D on the board, I'm just trying to project it. Okay. Just try it. ఇది అదే అంటే అది చూస్తే దట్స్ వాట్ ఎవ్రీ స్టెప్ యూ విల్ నాట్ గెట్ ద కంప్లీట్ అండర్స్టాండ్. That is why I'm giving you step by step, step by step. Even this is also not complete. Again, we will be discussing in the next class the same pressure belt, how the pressure belts are going to shift, what is the doldrums, etc. So, step by step. So, this one you will get more clarity. The next step you will get even more clarity. I'll ask Seshu sir to upload it immediately in the app. Anybody if is having any doubt, again go through the video on the same time. Because if you miss this, again the neglections will happen, again you'll forget this. And today only, if you have any doubts, again go back to the video and clear all your doubts. Okay? And everybody attend to the exam seriously. Every week we will give the exam. Explanations will also be given. Each are minute questions, explanations. Yesterday's exam explanations. Today I'll post you the 10 map pointings, 10 points in the group. I will also share you another material, earthquake zone 1, zone 2, zone 3, zone 4, zone 5. There is a classification of zones. So India, different places are lying in which zone, tectonic zone will be there. I'll post that also. Somebody remind me. Okay, after 6. This is subtropic high pressure belt, subpolar low pressure belt, polar low pressure belt. This is also polar low pressure belt. Polar low pressure belt. Polar low pressure belt. Subpolar low pressure belt. Subtropic high pressure belt. Equatorial. Pressure gradient force, Coriolis force, Ferrell's law, and pressure belts, prevailing winds, etc. Next class I'll tell you what is subtropic pressure, etc. What is that, doldrums, horse latitudes, etc. We'll continue in the next class. Okay. Take a gap of 10 minutes and write the test.